Good afternoon, folks. This is Mike coming back at you with yet another video on Intro to Algebra. In the previous video, we wrapped up Chapter 1 and we talked about simplifying algebraic expressions. In this video, we're going to start a new chapter. We're going to begin talking about a particular type of equation, and we're going to talk about the addition property of equality. So, as I just said, we are going to be focusing on a specific type of equation in this chapter, and it is the linear equation in one variable. As we get later on in other chapters as well, we'll be talking about other types of linear equations, but for this particular chapter, linear equations in one variable. And what is a linear equation in one variable? A linear equation in one variable is an equation that can be written in the form some number a times x plus some other number b is equal to 0, where a and b are real numbers and a is not equal to 0. And I specify the word can here. It can be written in that form. They won't always be handed to you in this form right here, but with a little bit of moving of some terms, you can turn it into something of that form. So a couple samples here. 2x minus 5 is equal to 0. That's already nicely handed to you in that form. 3x plus 5 equals 10. This is also an example of a linear equation in one variable. It's not directly in this form, but we can put it in that form. And negative 7x minus 2 is equal to 5x. This is also a linear equation in one variable. Some examples of things that are not linear equations in one variable. 2x plus 5y is equal to 0. We have two variables in here. Obviously, it's not one. Same thing going with this second guy here, x minus y is equal to 0. This guy right here is not a linear equation. It's not of the form some number times x plus some other number equals 0. We have an x squared here. Can't have that in a linear equation. Similar reason here, we have an x raised to the third power. Not going to happen. Not linear. So that's just a basic introduction into what a linear equation in one variable looks like. Now, the focus of this section, and the next couple sections as well, is to see how we can find solutions to linear equations in one variable. Back in chapter 1, we were given some value for our variable, and we were asked to check to see if it is a solution to the given, say, linear equation. Now we're going to find what the solution is. It's not going to be handed to us. We're going to find what this is. And to sort of help us visualize this property better, think of a scale. And when I say a scale, I mean those the old-time scales where you have the long arm and you have sort of plates hanging on each end of your bar, and you can put weights on one side or on both sides. So when you think of an equation, think of a nice balanced scale. I have weights on each end of my scale, and this scale is nice and balanced. And when we're solving these equations, we always want to keep things equal. We want to keep things the same. We want to keep things balanced. So if I were to add some weight onto this one side, then this side would be heavier, that side would go down, which means that side would go up. But the problem is I don't want one side to go down and one side to go up. I want to keep things exactly the same. I want to keep things how they were before I added this small weight. So what am I going to have to do to keep things the same? Well, I'm going to have to put that same weight over here. I have to add the same weight onto the other side so that things will stay balanced. And now, those things are nice and perfectly even. They weigh the same. Therefore, that's going to be a nice flat bar. Similarly, if I take some weight off of one side, say I take off that bigger weight there. Now this side has more weight to it. This side will go down, which means that side is going to go up. But once again, we don't want one side going down and the other side going up. We want to keep it equal. We want to keep everything the same. So what am I going to have to do to this side? Well, I'm going to have to take off that same large weight. And now, when I do that, we're going to have the same amount of weight on each side, and our scales will be even once again. And this is a nice visual and a nice way to think of working with what's known as the adding property of equality. Now, mathematically, in a strictly mathematical lingo, what it's saying is that if A, B, and C are all real numbers, then the equations A equals B and A plus C equals B plus C are the same. But we don't need something that technical. Really, all this is saying here is that if you have an equation to start off with, if you add or subtract the same amount from each side of the equation at the same time, then your equation still holds true, and you're going to have the same answers. So add one thing to one side, you have to add the same thing to the other side. Subtract one thing from one side, you have to subtract the same thing from the other side. And this following statement is one that you're going to see, hear, and use a lot in this class and in lots of higher level math classes. What you do to one side, you have to do the same to the other. What you do to one piece, you have to do the same to the other. And you have to do it at the same time. So keeping things balanced, keeping things even, keeping things equal. So a couple basic samples here. We're going to solve these equations below for x. And the idea here is to have x all by itself on one side of the equal sign. The point is to come up with something that looks like x equals and then some number there. So, first one here, x minus 12 is equal to 0. The whole point is to get, as we just said, x all by itself on one side, and then have some number on the other. So here, I have the x on this left side. Let's just keep the x there. Why not? So I need to get rid of this minus 12. I need to do something to this side so that I get rid of this 12. And then whatever I do to this side, I have to do to the other side of my equation. I have to do that same thing to the 0 as well. So what do I have to do to a negative 12 or a minus 12 so that I can get that to be gone and just have x all by itself on the left-hand side? Well, if I add 12, then I'm going to have negative 12 plus 12. That's 0. That gets rid of it. So by adding 12 on the left side, I'll just be left with x. But then, as we said, what we do to one side, we have to do to the other. And now we add going down each column. And we're just left with x is equal to, obviously 0 plus 12 is equal to 12. So that's all this is. Very basic, very straightforward use of the adding property of equality. You can add or subtract something from one side, and whatever you do to one side, you have to do to the other. Second one here, x plus 5 is equal to a positive 1. Very similar, slightly different. We don't have 0 on the one side. We have some other constant, but that's okay. Again, the whole point is to get x all by itself on one side and then just have some number on the other. So again, I have x by itself on the left-hand side. What can I do so that we just have x all by itself on that left-hand side? Well, how do I get rid of this 5? What do I have to do? If I subtract 5, I'm going to have 5 minus 5, and oh, that would give me 0. That would be perfect. But again, what I do to one side, I have to do to the other. So x plus 5 minus 5 is just x. And then 1 minus 5 is negative 4. So we have our solution of x equals negative 4. Just like magic, I've had a fourth problem spawn out of nowhere because that's the power of mathematical magic. So we're going to solve this fourth one here. 2x minus 3 is equal to x. The third one I'll let you solve on your own. So this looks a little bit nastier, but still something that we can just use our basic adding property of equality to solve. Here I see that I have a 2x. Here I see that I have an x. I want x all by itself on one side. Now, what if I subtracted x from both sides? Let's try it. Okay, well, I know that my right-hand side, if I have x minus x, if I take one thing and I subtract it from itself, well, that's just going to get me 0. And these two terms are like terms. I have a 2x and a minus x, so I'm going to combine those like terms. If I have two x's and I take away one of them, I'm left with one of them. So I have 1x left, or just x, and then minus 3. So x minus 3 is equal to 0. And now, again, get that x all by itself on one side. I'm going to leave the x on the left-hand side. I'm going to get the other number over here. So to clear out this negative 3, I have to add 3 on. And then what I do to the left side, I have to do to the right. So that leaves me with x. Then 0 plus 3 is 3. So as I said, the third problem I'll let you solve on your own. Guys, this concludes our video on the adding property of equality. If you have any questions or comments, please be sure to reach out to me, guys. Send me an email, stop into my office, give me a phone call, whatever you have to do. Otherwise, until the next video, take it easy.